Welcome to Math 200 Calculus. It's Statistics here at Cañada College. My name is Lapuz. In this video, we will go over a homework problem from section 7.2. Actually, the homework is labeled 7.2, but this is actually coming from a textbook that is different from ours. And it pulls from a section 7.3 from that particular textbook. Anyways, in this scenario, we are looking at creating a central limit theorem for the population proportions. So let's recap some of the notation that we have. Proportion is usually written as P or P hat, or sometimes P prime in this textbook that we're using. And this comes, the idea behind a proportion is that you're either in a success camp or you're in a failure camp or non-success camp. So it's really a binomial distribution. So all things kind of relate to binomial distribution. Binomial distribution. And we remember some of the formulas for the binomial distribution is that we have an n, the number of trials, and we have a p, the probability for each trial. And the mu, in terms of building a binomial distribution, starts out with n times p, and then the sigma becomes the square root of n times p times q, and q, if you remember, is equal to 1 minus p. So that's some of the background facts that we might be useful for us. Now, in terms of, before we even get to the problem, maybe we'll move this problem down a little bit. Before we even get to the problem, we're going to set up our distribution. So sampling distribution. We'll have a variable p prime. So instead of having the variable x, we'll call it p prime, or instead of having the variable mu, we'll call it p prime. So our p prime will have a number line, and then the mean that we'll use for this p prime is, so this is for the regular distribution, but we're talking about the binomial distribution. But when we're talking about sampling distribution for proportion, we're actually going to be using the p that's given from your binomial distribution. So that's going to be the mean. Now the standard deviation, sigma, I should call this mu sub p prime, is going to be p, and sigma sub p prime is going to essentially be this thing divided by n. So there's some algebra that happens where it really just becomes p times q divided by n. All right. So at this point, let's not worry about how they got there. All we know is that these two, mean and standard deviation, is going to be our new mean and standard deviation for a normal distribution. So in terms of the sampling, I think they call it x sub p, is going to be a normal distribution where your mu is going to be the mu sub p prime, and then your sigma, it's going to be the sigma sub p prime, and it's going to be given by this. All right, so if all that stuff with variables gets a little bit confusing, let's not worry about it too much. Let's just focus on what's highlighted here, and what you need to find are the mu and the sigma. Okay, so let's take a look at this problem. In an effort to cut costs to improve profits in the U.S., the companies have been turning to outsourcing. In fact, according to Purchasing Magazine, 54% of the companies surveyed outsourced some part of their manufacturing process in the past 2 to 3 years. Suppose 555 of these companies were contacted. So already from here, we should be able to identify what we're needing. So we need P, or I guess we should start with N. So N is the number of samples and trials for our binomial distribution. That's 555. And then P is that for each of them, the probability that we select somebody who's outsourcing is about 54%. So I'll write it as a decimal. And that's what's needed to get us going for our distribution. Now, given that information, we can already jump to the idea of finding out our sigma, or I guess we'll start with the mu sub p prime. So this is going to be the mean that we'll use for our standard normal distribution, or our normal distribution. And this is just going to be 0.54. And then our sigma, this is something where we have to do some computation. It's going to be the square root of 0.54. That's P. We're going to multiply this by Q, which is 1 minus P, 0.54. That's 1 minus 0.54. And we'll divide it by N, 555. Okay. So let's take a look at those. And some of your problems, they're actually asking you these pieces of information. So this is good to know. So we'll start off with N being 555. Our P is going to be 0.54. And you can certainly do all this in your calculator. Mu, our mean, is going to be equal to just P. So I'm going to say equals and click on this. And our sigma will be some computation here. So this is where we're gonna use this and take a little bit of work. So this is going to be equal to the square root SQRT in Google Sheets, and the value that we're looking at is going to be P times, and I'll put a parentheses, 1 minus P, and then close the parentheses. So those are the two things being multiplied, and we'll divide by N, 55. All right. So I got 0.2115579. For these things, I know it's hard to keep track in the calculator, but it's good to, they're going to ask us to round a percent to 2 decimals. So if that's a regular decimal, that's 4 decimals. So I want to go more than 4 decimal places. So 0.2115, and then I'll do one more. So that's 57. So I'll round up to 6. Okay. So that is our mean and our standard deviation. Okay, now let's actually start to answer the questions. And the first question, what is the probability percentage that 338 or more companies outsource? So we were looking at this as a probability as 338, or some X value is bigger than 338. But this is not really what we're looking for. But we're looking for something similar. Since we're living in the P prime, it's not going to be this anymore. So let me scratch this all off and say, hey, this isn't quite what we're looking for. We're looking for an X value with a P prime. And so X, if you remember from our normal, or from our binomial theorem or binomial discussion, whenever we have X, it's going to be X is equal to B, or I'm sorry, I think the P is X over N. So that's one of the other big formulas that we had for finding our proportions. It's going to be X over N. So if we're looking at the X of P, we're looking for really a P value. So the P value that we're looking for should be represented by the X value that's given. So that's 338. and we're dividing it by the n, which is 555. Okay, so what we're really looking for, instead of we're looking for this probability, we're looking for the probability that x sub p prime has to be bigger than this number 338 divided by 555. Okay, so we need to find that out. So let's get this done here. So your x sub p, I'll say capital X and then this little underscore p. This is just notation and it's not important at all. But this computation is important. So this is equal to 338 divided by 555, and you get 0.60900 or 901. So we can write that down. So this is equal to 0.6090001. So I mean 0.09, so that rounds off to 1. Okay, now this is what we're going to use in our normal distribution. So whether you're using a calculator or whatever, I'm sorry, I think I wrote this wrong. I want this to be inside here. So let me scratch that out and say what I'm really looking for part A is I want to find P, the probability that I have this variable to be bigger than 0.60901. Okay, and so whatever technology you're going to use, normal CDF in a calculator, this is your X, this is your, so it has to be bigger than that. So it'll be this thing, 1e to the 99. Let me write it down for calculator, TI 84. You'll say normal CDF. And then your minimum value, which is going to be this number, 0.60901. And then the infinity, 1e to 99. And then your mean, which is 0.54. And then your standard deviation, which is 0.21156. Okay. We're using Google Sheets. So let's plug that in what we need to do. So remember in Google Sheets, we had to do, if we were looking at the area to the right, I probably should have drawn this. If we're looking for the area to the right of 0.6, so the mean is 0.54. And so 0.6 would be over here somewhere, 0.60901. And you're looking for this area over here. Okay. So back to using this Google Sheets, we have to do the normal distribution collects areas from the left onto some number, but we want to go from that number to the right. So it'll be the complement of that, which is using 1. And then here is norm .dist. So norm distribution. And let me just check. I believe when you do the norm distribution, they're looking for the x value. So the x value is this number. We have it written here, so I'm just going to click on that. And then the mean, which is this number mu, and then the standard deviation, which is this number here. And then we want this to be cumulative. So we'll put a comma and then true. You can just put a number 1 there and that'll be okay. And I think I forgot the 1 minus. So let's put 1 minus here. 1 minus, oops. Let me put it from here. 1 minus that value. And then press enter. So again, this is your X value, which is 0.60901, comma, your mean 0.54, comma, your standard deviation 0.21156, comma, true for it to be cumulative. Okay, so we should get the same results, and the results should be this. So they want it as a percent. So this looks like it's going to be as a decimal 0.123. So 123 and then 5. So let's just call it 6 because you're rounding off to 4 decimal places. So as a percent, this becomes 0. So the new decimal place would be here. So that's 0.6%. Okay. All right. So that's the first one. That's part A. Part B, what is the probability percentage that this or more companies? So I think it's basically the same thing that they're asking. So we can run through the same idea. So maybe I won't do the commands anymore. I'll just do what's actually needed here. So for part B, you want the probability that x sub p prime is bigger than this number. So remember, this is the x number, and we want that to be the p prime number. So the x number is going to be 285, and then we're divided by 555. Okay, so whatever that might be. And then again, we have our mean and our standard deviation that you can use, and then you'll just use the same formulas. So let's take a look at part C. Part C is saying probability, the percentage 48 or less of these companies. So that's a probability, or that's a proportion that they gave. So that already is a proportion. So for part C, we're looking at the probability that the proportion that they give you is actually 0.48. So you want it to be less than 0.48. So I want to say the proportion was given. Whereas for this one, or for these other two, the X was given. Need to translate to P prime, and P prime is equal to X over N. And the same thing happened up here. All right, so this time it's a less than, so the normal CDF formulas, the formulas for this would be slightly different. So this would be for the TI-84, this would be normal CDF of, looks like I need a second here. This should be normal CDF. I should have drawn it. So this time it's being shaded on the left side, 48%. So it's going to be negative 1e to the 99, or something really small. And then we have the value 0.48. And then we have the mean 0.54 and a standard deviation 0.21156. And similarly for the Google Sheets, this time you don't need the 1 minus because it's on the left side. So because it's on the left side, you just do norm dot distribution. And then the value that they gave, 0.48. And then the mean, standard deviation, 0.54, standard deviation, 0.21156. And then true, because it is a cumulative distribution that we're looking for. Okay. All right, so that's the general idea behind these types of problems. And again, the key is to know your mean and your standard deviation, and then to translate all your x values into the p prime values. Okay. All right. I hope that helps, and good luck to you.